This is the beginning of the second video to section 2.3. In example 8, we have 11 salaries, and we're first asked to find the median. What we will want to do is order all of this data from smallest to largest. So go ahead and turn off the video for a moment and order this data. We're asked to find the median first. And if you recall, the median will be the center of our data, where 50% of our lower data and 50% of our upper data will be split. And if we actually count how many pieces of data here, and we have 11, our very center of our data will be at 54,000. Right here. Now, we had an exact value for our median here. Sometimes it won't be that simple because we may have two numbers equally sharing the very middle place. If, for instance, we had two data points being our center value, we would have to add both of them and divide by 2 in order to get our median. We'll do some of those shortly. Now, let's go ahead and find our first and our third quartile, which we label as Q1 and Q3. Our first quartile is going to be the middle of our first half of data. So if we look at just our first half of data here, just these 5 values, notice that 40,500 falls in the very center of this data. So our first quartile is 40,500. For our third quartile, we have to look only at our second half of our data. So just these 5 values right here. Which value falls in the very center? That would be our 69,000. So our third quartile here, or our Q3, is 69,000. Next, we're asked to find our interquartile range. And in order to do that, we subtract Q1 from Q3. And we'll get $28,500. Now next is a bit of a tricky part. We are asked to see if we can find any potential outliers. So what we must do is take this value right here, and we need to multiply it by 1.5. And that's going to be 42,750. Now, once we have this value right here, we have to subtract this value from Q1, and then we have to add this value to Q3. This is tricky. So subtract that value from Q1 and add that value to Q3. So let's go ahead and do that, and then we'll go ahead and we'll get our answer. So here are the two test numbers we have. Now let's answer the question, are there outliers? If any piece of our data up here if any piece of that data falls beneath this number or above this number, we'll have an outlier. So let's take a look. Does any of our values up here fall less than negative $2,250? No, they do not. Do any of our values fall above $111,750? Let's look. Yes, one value does fall above $111,750,000. So that means that yes, we do have an outlier. $120,000 is an outlier. If we take a look at example 9, we'll see we have a problem with 40 bus drivers, and they were asked how many hours they spend each day running their routes. We're asked to find the 65th percentile. We can do this a couple ways. Notice in the cumulative relative frequency column, we have our 65th percentile right here. So what does that mean? 65%, we'll write that as a decimal, of our total number of pieces of data, which is 40, comes out to be 26. That means 26 pieces of data fall beneath the 65th percentile. If we're looking at 26 pieces of data here, that's going to include our first 12 twos, that's 12 pieces of data, in addition to our 14 threes, 12 and 14, that gives us 26 pieces of data. That means our 65th percentile is going to fall between the last 3 and the first 4. So our 65th percentile is going to be the midpoint between 3 and 4, which will be 3.5. If we are looking for our median in letter B, the median is our 50th percentile, or the very center of our data. Since we have 40 pieces of data, that means our 50th percentile will give us 20 pieces of data below and above our median. Our actual median is going to fall between our first 20 pieces of data and our second 20 pieces of data. Well, let's find out what number that is. Our first 12 pieces of data is a 2. And then we have 14 pieces of data that all equal a 3. So that means our 20th value is a 3. It also means our 21st value is a 3. So if we want to find our median here, our very center piece of data will be the average between 3 and 3, which is 3. Lastly, we're asked to find our third quartile. Our third quartile is at 75% of our data. 75% of 40 gives us 30. So that means the third quartile lies somewhere between our 30th, 31st piece of data. and our 30th piece of data is 4. Our 31st piece of data is 4. So our third quartile is also. As you go over this, please keep in mind we are going to include a video on how to find the median and the quartiles on your graphing calculator. This is how you would do it by hand. On the next page, we're asked to interpret percents, quartiles, and medians. Keep in mind, deciding whether a certain percentile is good or bad depends on the context of the problem. For instance, in example 10 on an exam, would you want to get a grade with a high or a low percentile? Most likely, you would prefer a higher grade. So on an exam, a higher percentile is preferable. However, let's look down to the next example. Let's consider runners in a race. Is it more desirable to have a finish time with a high or a low percentile? In this case, we would rather have a lower percentile. Taking a look at letter B, the 20th percentile of run times in a particular race is 5.2 minutes. What does this mean? This means 20% of runners finish the race in 5.2 minutes or less. 80% of the runners finish the race in 5.2 minutes or longer. Moving on to letter C, a bicyclist in the 90th percentile of the race finished in 1 hour and 12 minutes. Is he among the fastest or the slowest? He's among the slowest. 90% of the cyclists were faster than him. So be careful when interpreting percentiles and quartiles. It depends on the context of the situation, whether you would like a higher percentile or a lower percentile. That's the end of the video for section 2.3.